Lesson 35. Integral of a constant. Integral of k of f of x. Integral of x to the n. Integral. Do we remember what that word is?
Integral. It sounds good.
Choose a different vocabulary word. Integral. What is an integral equivalent? Taking the...
Oh, is that when you stretch it out?
There we go. An integral is taking the antiderivative. Okay, I wasn't looking for a word that sounded like. Okay, so rewind. Last week, I think it was, we had our first ever lesson of antiderivatives. So in the same lesson, I introduced antiderivatives, which is undoing your derivative. But also, what you commonly, it doesn't say find the antiderivative, it's more going to be find the integral. Okay, so if we start with the basics here, let's look at this example A. Start with the basics, what we know solidly by this point, I hope. If f of x is 5x, what is the derivative? Or in other words, what is f prime of x? 5. Okay, so the derivative, typical power rule for derivative, you subtract 1 from, or you take the exponent, multiply it out front, subtract 1 from the exponent, right? So 1 times 5 is 5, subtract 1, it's x is 0, so just a 5. Okay, so now the question becomes, reverse this. What is the integral of 5 dx? So if the derivative of 5x is 5, what is the integral of 5? 5x. And don't forget, when we do this, it's a plus c. Because technically there could be some constant term that you would take the derivative of, and that derivative would be 0. Very possible. Yeah, we did this back in like lesson 31, 32, I don't know. Recently. Okay, we had our first introduction to this. So, okay, the rule here is the integral of k dx. So the integral of a constant is the constant times x and then plus c. Let's try to look and see. We did this back in lesson 32. Okay. Remember, this is the one we start off with. There's 3 different things you had to take the derivatives of. They were all 2x. It was like derivative of x squared is 2x. Derivative of x squared plus 42 is 2x. Derivative of x squared minus 165 is 2x. Okay, so that's why we always have the plus c. So this part right here is a little bit of what we've done, but if you have a constant, and you're doing that integral, you're going to add an x back in. That's what's happening. So, this one, integral of a constant times a function. So, right here, forward thinking first, if f of x is 5 sine x, then what is the derivative? So, think back to, this is what you already know, 5 sine x. What is the derivative of 5 sine x? 5 cosine x. Because you keep the 5, and the derivative of sine x is cosine x. Okay. Reverse. So what is the integral of 5 cosine x? 5 sine x plus c. Because again, you're going to keep the 5. What is the integral of cosine x? So what is it that you take the derivative of to get cosine x? And then, as always, plus c. Now, what you'll see, and I'll write this a little bit just to kind of show it to you, the rule that they are showing here is that if you have a constant times some function, such as in this case, it was a constant 5 times a cosine x. Basically what they're saying is you can move that 5 out front of the integral, just kind of separate the 5 in your brain, and then just do the integral of cosine x. And the integral of cosine x is sine x plus c. I'm not saying you have to move that constant out front, but that's essentially what our brains are doing, even if we don't think that exactly. So example 1 here. The integral of 4 cosine t dt. What this rule is saying up here is that basically this 4 is a constant. What's that 4 going to do? It's just going to carry along to your answer. And so that rule, I'm not saying you have to do this, is just saying that you can rewrite this, if that is helpful to you, to where the 4 is out front, because it's just a constant. So you can move that 4 over the integral. And so we're going to do 4 times whatever the integral, or the antiderivative, of cosine is. Okay, it's just a notation thing. So, keeping the 4, what is the integral of cosine? Okay, sine t, and then of course the plus c. Because, how do I get cosine? I take the derivative of sine. Okay. Integral of sine u du. Last one had t and dt, so we had our answer in t. This one has u and du, so that just means my answer is going to be in terms of u. So integral of sine u. So it's what do I have to take the derivative of to get sine? So my answer is going to be negative cosine u plus c. Now again, if you're struggling with these sines and cosines, side note. Whoops. If your function is cosine x, what's the derivative of cosine? Derivative of cosine is negative sine x. Started to get myself confused. Okay. So what that means is, look at this one right here. If we want the integral of sine, well, generally speaking, the integral of sine is cosine. Except since this wasn't negative here, we have to change the sign here to become a negative. Does that help? Or maybe it confuses. I don't know. The other side note to remember is if f of x is sine x, what's the derivative of sine x? Derivative of sine x is cosine x. You have to know those two derivative rules solidly. Okay? Because you have to be able to work them forwards and backwards. Okay. Last rule for the day. And this is the big one. Okay? You'll get to a point where you'll use it fluidly. But we have to address it right now. Okay. So we've got to deal with these powers. What is the derivative of x to the fourth?
4x to the third.
Are you guys okay with 4x to the third?
Yes.
Pull the 4 out front, subtract 1 from the power. Old news, right? We've been doing that for a while now.
Yeah.
Okay, so if the derivative of x to the fourth is 4x cubed, what is the integral of 4x cubed? X to the fourth plus c. Even if you don't understand why, you see the relationship here, yes? So even if you don't know how you'd find that on your own, which we'll talk about, that's what it is. Now, we have a rule here stated, yes? Looks more confusing than what it is. As I said, once you get a chance to practice at it, it will become fluid to you. So the integral of x raised to some power dx. So what it says to do. So if you're doing the integral of x to some power, with the derivative, my power decreases. So with an integral, my power is going to increase. So notice it says n plus 1. So you add 1 to your power. Now, it then says to divide by n plus 1. So what I always think is you add 1 to that power, and you divide by the new power. And then, of course, the plus c. So, let me practice real quick with this example right here. 4x to the third. If we use the idea of x to the n. Okay? What is my n? My n is the power. What's the current power? N equals 3. So if you use that, so now my antiderivative, or my integral, is x to that power plus 1. Now keep in mind, there's a 4 in this problem. So what's that 4 just do? Carry it along. X to the, it was 3, so what do I do with 3? I add 1. Divided by n plus 1. So what is n plus 1? That 3 plus 1. So that's me writing the rule out right there. Now, clean it up though. Does it make sense? 3 plus 1 is a power of 4. We got that. Denominator of 3 plus 1 is 4. What happens with that 4? It cancels with the coefficient of 4 that was already there. And then are we at x to the 4th? Yeah. Again, it will become fluid once you do it some. You just have to give it, especially with the, normal whole number positives. Okay, let's try example 3. The integral of 5s to the negative 20 ds. So, okay, add 1 to the power. So I'm going to keep the 5 as is. 5s to the, and I'm going to write it as negative 20 plus 1. I won't normally do this. This is my making sure I don't lose anyone, right? And then what else do I have to do besides add 1 to the power? Yeah, divide by whatever that negative 20 plus 1 is. And of course, don't forget, plus c anytime you do those integrals. Now, needless to say, do I want you to leave your answer like that? Absolutely not. So, there's a 5 s to the negative 19 over negative 19 plus c. Now, I'll be honest, you wouldn't exactly see it like this usually. Usually I would think of it as a fraction out front. So I would normally think of this as negative 5/19 s to the negative 19th plus c. How can I check myself here? If we just did the antiderivative, what will undo that? The derivative. So if at any point you're like, I'm just not feeling very sure about myself, check by taking the derivative. That doesn't mean you have to write the derivative down. That just means that's your check there. So, if I do my derivative, I'm going to do a verbal check. I'm not going to write it down. Power, we multiply by the power out front, yes? Power is negative 19. So if I multiply negative 19 times negative 5 over 19, what happens? My 19s cancel. My negatives become a positive, and I have positive 5. S to the, what do we do to the power? We subtract 1. What's negative 19 minus 1? Negative 20. Is that where my original problem was? Yeah. Okay, so I feel pretty confident. But that's how you can check yourself. Okay. 3 more to practice with. Now, notice, are we giving you the easy ones right here? No, you get some fancy powers to work with. Okay? But that's good because that will give us a chance to solidly learn the rule, I hope. Okay, example 4. Are we ready?
Yeah.
What would be helpful before I start this problem? We need it to be a power, don't we? We don't have a rule to take derivatives or antiderivatives of radicals because they can become powers. So before I ever start the problem, this is going to be the integral of 1/3 t to what power? 2/3 for what I'm doing right now, dt. Are we okay with that? Okay, so now we're ready to take our integral. Okay. Integral's rule says, do what first? Add 1 to the power. So I'm going to keep 1/3 t to the, what is 2/3 plus 1? 5/3, right? 2/3 plus 1 is 5/3. Oops. Because 2/3 plus 3/3, are we all there? Maybe we're all there. I hope we're all there. Okay, what else do? I add 1 to the power and then what? Divide by the power. So that means I'm dividing by 5/3. And? Okay. I'm going to write on the plus c, just because I don't want to forget it later. Obviously, we don't leave it like this, right? What do you know about dividing by a fraction? It's multiplying by the reciprocal. So dividing by 5/3, I can move up to say multiplying by 3/5. So think 3/5 times 1/3 t to the 5/3. Again, as you get better at this, you'll do this all in your head. 3/5 times 1/3, the 3's cancel, and you have 1/5 t to the 5/3 plus c. Did you do a mental check? Derivative, multiply by 5/3. Well, 5/3 times 1/5, the 5's happen to cancel, and you get 1/3. Subtract 1 from 5/3. Well, 5/3 minus 3/3 is 2/3. So it makes sense. Okay, example 5, unless you have a question there. If you have a question, speak up. What do you know about the integral of 3 du over the square root of u? Three stays 3. What do we know about the square root of u? That's u to the 1/2. But it's in the denominator. How do I get out of the denominator? Make it negative 1/2. So integral of 3u to negative 1/2 du. Okay. Do what? Okay. 3u, add 1 to the exponent. What's negative 1/2 plus 1? Positive 1/2. And then what do? Divide it by that positive 1/2, and don't forget, plus c. What is 3 divided by a half? 6. Because if I take 3 wholes and divide them into halves, they're 6. Or multiply by the reciprocal. 3 times 2 over 1. 6u to the 1/2 plus c. And last one. First of all, that does say the integral of 5z to the pi dz. That is a pi. Pi can be a power. It's a number. Okay. Follow the rule as we've been doing it. So what's the first step? Add 1 to the power. So 5z to the pi plus 1. We're going to write it as pi plus 1. That's fine. And then what? Divide by that new power, which is pi plus 1. Don't forget, plus c. This one, in all honesty, I'm going to clean it up kind of, but this is pretty neat as well. I'm okay with this. The other option is to pull all constant pieces out front and say 5 over pi plus 1 times z to the pi plus 1 plus c. I'll be honest, I'm not sure that's a whole lot neater. They're both equally good in this case, in my opinion at least. This just officially you have your constant, your coefficient pulled out front. So not horrible, right? You just have to practice the process. And now when you get easy numbers, it should be really easy since we've worked with more difficult numbers. That's my hope. Okay.